All right, for number 23, it says which graph best represents the line passing through the point 0, -6 and is perpendicular to the line y equals 3/2 x. The first thing to check, since it is a multiple choice test or question, I want to see if it is going through the point 0, -6. And if I look at these, the only one that doesn't go through that is B. 0, -6 would be down here. Okay. And B doesn't, so I can take that out. The other thing that I'm looking for is perpendicular. That means I look at the slope, there's 3/2, and I want to flip it and change the sign. So my slope, my perpendicular slope is going to be -2/3, which means C is out because this is going to have a positive slope on it. So I can automatically eliminate that. And then so if I'm at 0, -6, my slope would tell me that I go up 2 and back 3 is one way of looking at it. I could also look at this as going down 2 and right 3. Either way, looks like that's working for A, so A is the right answer. Just to show you that on the next problem, if I look here and I go up 2, back 3, that puts me right here on D, which is not on that line. It's right next to it. If I zoom in, you can see it a little better. It's right here, the next little square over. So that one is not it either. A is the right answer. Now for number 24, it says, which of the following best describes the graphs of the equations below? All right, so it's looking at it, the y-intercept, x-intercept, and parallel versus perpendicular. So for that, what I want to do is I want to rewrite these two equations. All right, I'm solving for y, so let's say if I move this 2x across the equal sign, it's positive here, so it's going to become negative. So I'm looking at y is equal to -2x plus 4. If I rearrange this one, the y is already by itself, but it has the 4 right here, so I'm going to have to divide everything by 4. Doing that gives me y is equal to 1/2 x plus 1/4. So this tells me that they don't have the same y-intercept. Okay. When I'm looking at it, I look at my slopes, and I notice that I have a -2/1. Since that's a whole number, I can put it over 1. And then I have 1/2. Those are opposite reciprocals. I flip the 2/1 to make it 1/2. This is negative and positive. That would mean opposite. So I do know that they are actually perpendicular. Now if I'm checking to see if they have the same x-intercept, that means that you're going to let the y value be 0 and solve. So if I had 0 is equal to -2x plus 4, solving that would give me the x-intercept, just as a review in case you needed to check that one. And then remember that parallel means that the slopes are the same. All right, now on number 25, it says which of the following is the equation of the line that passes through 2, 1 and is perpendicular to the 5x plus y equals 9. First thing to do again is to rewrite this in slope-intercept form, since that's what my choices are. So if I have y is equal to -5x plus 9, because again I'm moving this over across the equal sign, so I have to change the sign. Right. And so if this is negative and I want it to be perpendicular, and I'm looking for a slope to be positive 1/5, and so that gets rid of actually all my choices except for C. So C would be my right answer. In case that there was 2 positive 1/5 for the same slope, you would have to substitute these values in. Let's just say that I had, I'm solving for y equals, then I would have 1/5 2 plus 3. And I want to check to see what my answer becomes, if I would get this 2, 1 as an answer. All right, looking at this, my apologies. This should actually be 1/5 x plus 3/5. You should have a fraction for the y-intercept. All right, moving on to number 26 right quick. It's asking for a translation that maps S and T. So to do that, we're going to look at what happened to R. And so from R, I'm going to go over Looks like we went right 8, and then I went up 2. So if I do that for S, I'm going to go right 8, and then up 2, which would be here. This would be my S prime. That's going to be 4, 3, which looks like is this one. And just to double check T, I'm going to go right 8, and then up 2. That's going to be 9, 8. That should be T prime. So yeah, that does work. G is the right answer there. I'm just counting left or right, and then up or down. For number 27, it's asking me to reflect this point, -3, 2, across the y-axis, and what's the resulting image. Okay, reflecting across the x or the y-axis. If I'm here at -3, 2, and I reflect across the y-axis, I'm going to go the same distance on the other side. So that's going to put it there, which would be +3, +2. So D is the right answer for a reflection on the y-axis. All right, looking at number 28, the opposite. Looks like I took my 2 and I put it in the front, and I changed the sign. So I did the opposite of B and A, because the force stayed positive. So that is going to be a 90-degree rotation counterclockwise. All right, number 29 says triangle DEF with vertices 1, 2, 3, 4, and 1, 4 is reflected across the y-axis. Then its image is reflected across the y equals x line. Which single transformation moves the triangle from its starting position to its final position? For this one, what I want to do is I'm going to look at just one of these points. And I know that 2 reflections is the same thing as 1 rotation. So that tells me that I'm either looking at A or B. And then I want to look at a point. I'm going to pick one. I'm just going to call this, I'm going to start with D since that's 1, 2. And it says that I reflect it across the y-axis. So that's going to put it over here at -1, 2. And then reflect it across the line y equals x. So if I come up here and I reflect it, it's going to come down this direction. I'm just going to actually put this at 2, -1. All right, so the question is asking me, kind of shortcutting this, if I want to go from 1 to 2, and instead of doing a reflection followed by another reflection, how can I get from 1, 2, this point 1, 2, to this point 2, -1? So if I let my 1, 2 be my A and B, what happened is that I put the B in front, and then I switched the opposite of A. So looking at my different transformation rules, that actually ends up being a 270 degree rotation about the origin.